and multiplying them. So let's look at the first example and talk about polynomial. What a polynomial is just a bunch of letters raised to different powers. And the thing we need to understand is y squared can only be added or subtracted to y squares. Y's can only be added or subtracted to y's. Y to the third power can only be added or subtracted to y to the third power. So what we have here is 4 of these. Don't think of that as 4 times. Now, this time we want to think of it as 4 apples. Here's plus 1 apple, minus 8 apples, minus 2 oranges. These are different than these. Okay, so this is an object. 4 of these, that's the same object as 1 of those, and that's the same. So combining terms, then what we can do is combine the y squares. So we have 4 plus 1 is 5, minus 8 is a minus 3. And here we have a y, and adding those up, that's the only one we have, is a minus 2y. So that's a very simple problem, but listen to what I'm saying, is that polynomials are, letters to powers, and you can only add squares to squares to squares, and cubes to cubes, and so on and so forth. And you're adding how many of those you have. You have 4 of those, 1 of those, and a minus 8 of those. And that's all there is to the basic concept of adding polynomials. Just remember, you have to add apples to apples, oranges to oranges, pears to pears. All right, let's look at the next example. Next example is saying, okay, well, we must remove the parentheses first. So let's do that. This is a plus 1 in front of this, so 1 times that is 3x squared. 1 times that is a plus 2x. 1 times that's a plus 2. Now that's a minus 1. A minus 1. So minus times an x squared is a minus. A minus times a minus is a plus 2x. And a minus times a minus is a plus 7. Now, remember, add apples to apples, oranges to oranges. So x squares added to x squares. So that's 3 of those, minus 1 of them. So that's 2 of those. And then we're going to take x's. So we have 2 x's here and 2 more x's, which makes 4 x's. And then we have numbers. Plus 2 and a plus 7 is plus 9. Right. So the point is, remove parentheses, add apples to apples, oranges to oranges, and so on and so forth. All right, let's look at another example. Okay, example 4 is the first thing I do is remove parentheses. And then a minus 1 times that is a minus x squared. A minus times a minus is a plus 4x. And now I add apples to apples, so that's 4x squared. Oranges to oranges, it's a minus 2 of those. And then numbers is just a 7. Okay, that's the concept to hear about adding and subtracting polynomials. Let me just over here to the side talk about this. If I have 5m squared n plus 6m n squared, you can't add those. If I have 2 letters here, 2 or more letters, then they have to be the exact same powers. This is a different object than this is. Okay, let's go to example 5. And what I have here is multiplication. All right? So I have x times 7x, which is 7x squared. And then I have x times a minus 10, which is a minus 10x. Okay, this is called the distributive property. What you're doing is you're going to take whatever this is in front of the parentheses and multiply it times everything inside. Multiply it times everything inside. multiply it times everything inside. Well, x, this is a 1, so numbers times numbers. 1 times 7, that's 7. And then x times x is x squared. All right? Next example is number 6. Okay, we're going to distribute that to everything inside. So this times that. Well, numbers times numbers. Minus 9 times a minus 2 is a positive 18. And a times a, you add powers. You multiply this times this, you add powers. All right, numbers times numbers, so that's a plus 27. And then a, this times this is add powers. And then numbers times numbers is minus 63, and then letters, a cubed. All right. And this is working on the concept of the distributive property. Distributive property. Okay. Now let's look at number 7. I want to show you 2 ways of working 7. The notes, written up notes, have what's called a distributive property. What it's going to do is it's saying I'm going to multiply this x times everything inside. So that would be 4x to the 5th. And then x times this would be a minus 3x to the 4th. And then x times this would be a plus 12x. Then it's going to come back and take this one and multiply everything in there. So that's going to be plus 16x to the 4th minus 12x cubed plus 48. Distributive property. This times everything, and then this times everything. And now we're back to adding apples to apples, oranges to oranges. All right? Well, we don't have any more x to the 5ths, but we do have x to the 4ths, so that's minus 3 plus 16 of those, so that's plus 13 of those. And then we have just the x cubed, and then we have numbers, which would end up being 60. And that's the distributive property concept. All right, what I'd like to show you is another way of doing this, which is just as easy. And you already know this concept. If you multiply 235 by 12, you multiply this times the 235, then you multiply this times the 200, and you multiply this time and you put it here. And then you multiply this, you put it here. All right, and you add. So we can do the same thing with this problem. What we can do is go put the x plus 4 over here underneath it and do long multiplication. So 4 times this is 48. 4 times this is minus 12x cubed. 4 times this is 16x to the 4th. Now we come back and multiply x times this. X times this is 12x. Can't put that, so I'll put it over here. And then x times this is a minus 3x to the 4th. Minus 3x to the 4th. And then x times this is 4x to the 5th power. And adding those, you get the same answer. If you'll notice while I go on and go back and look at the tape, you'll notice I had a 12 and I added it to the 48, and I was supposed to add a 12x. Okay? All right. So this is the correct answer. In my opinion, this is a safer way of being able to work the problem. For instance, what if we had had a trinomial up here? then if you just put that underneath here and do long multiplication, it's the safest way to do it. As my example shows you, this is a safer way. It's a little more accurate than the other way of doing it. Okay, let's look at the next example. Now I'm going to show you 3 ways of doing this problem. Okay. One is the distributive property. I'm going to multiply this times everything. So that's 6x minus 15. Then I'm going to multiply this times everything. That's 2x squared and minus 5x. Well, in mathematics, we're supposed to put the highest power first, so we would rewrite this as 2x squared. Then adding the x's, we get 1x, and then the number. All right. So that's the distributive property. Okay, now, the other way of doing the problem is to write it down like regular multiplication that you know how to do. So 3 times that's a minus 15. 3 times this is 6x. X times this is a minus 5x. X is going underneath x's. And x times the 2x is 2x squared. When you add, you get the same answer. So the process is just learn how to get the job done. It's not that you have to do it a certain way, one and only one way. Just get the job done. Algebra really is nothing but arithmetic with letters, and it looks more complicated, but you still use the same concepts and methods. All right, now what I want to do is to show you what's called the FOIL method. And when you have a binomial, 2 terms, and a binomial, 2 terms, then this is the way to multiply it instead of doing all the other methods. Now the FOIL method says first times the first, the outside, the inside, and the last times the last. So the first times the first is 2x squared. The outside is minus 5x. The inside is 6x. And the last times the last is minus 15. And when you simplify that by adding like terms, you get the same answer. All right, so I'm going to erase this and I'm going to show the problem all over again the way I do it. Okay, so I'm going to have x plus 3 times 2x minus 5. Now here's the way I do it. And this is the method, to me, that the other tapes you're going to do on factoring, this is the way you have to think it. First times the first, that's 2x squared. Last times the last, that's minus 15. And then this added to this. So this is 6x minus 5x, which is plus x. Okay, that's the FOIL method. So I'm going to work a bunch of the FOIL method. So let's now go to example 9. All right, example 9, FOIL method. First times the first, 2x squared. Last times the last, minus 15. Inside is 6x, added to a minus 5x is plus x. All right, number 10. Number 10, FOIL method. First times the first, x squared. Last times the last, minus y squared. Inside plus the outside is 0. They drop out. You get a plus x. I'll just go ahead and write it down. You get a plus xy and a minus xy. These add up to 0. Final answer is x squared minus y squared. All right. Now you're going to have to factor like these a bunch later on in the course. Okay, that's the FOIL method. Let's go to example 11. and look at the FOIL method on this one. All right, first times the first is 2x to the 6th power. Remember, when you multiply x times x, you add the powers. And then the last times the last is plus 4. The inside now is a minus 8x squared, and the outside is a minus x to the 4th. And this time those don't add up. So you just leave them there. Now, normally, in the back of the book, you're going to see this answer is 6. They're going to put the powers in descending order. But this answer here was correct. Okay, it's not wrong. All right, first times first, last times the last, inside plus outside. That's the FOIL method. That's for binomials. Okay. First times first, last times last, inside plus outside. All right, let's now look at example 12. These are some just special cases that I want to show you. If you have a parenthesis squared, then what that means is the parenthesis times the parenthesis. And now do the FOIL method. First times the first, last times the last, inside plus outside. So you have inside is AB, outside is AB. Add those, you get 2 of them. All right. Now, notice this. If you have x plus y squared, it's x squared plus 2xy plus y squared. Now you can write it down twice and do the FOIL method. That's the safe way to do it. But I want to show you a shortcut. For special cases, binomial squared. It is simply the first one squared, the last one squared, and this times that times 2. Just double it. So it's the first one squared, a squared, last one squared, and then a times b doubled. Notice, x squared, y squared, x times y doubled. And if this is a minus, it'll be a minus in here. Okay. That's, if you just pick up on that, it saves you some work. But if you have a binomial squared, then it's simply the first one squared, last one squared, multiply them together and double it. Let me show you another example. If I had a 3 in here, okay? Then this would be 9a squared plus b squared, and then this times this is 3ab, double is 6. Okay? All right, let's go to 13. Now let's do 13 real quick by our shortcut method. This would be first one squared, last one squared, and then that times that doubled. Okay. Or just write it down twice and do the FOIL method. First times the first, last times the last, inside plus outside. All right, practice, you got it. Practice, you got it. Okay. All right, let's take number 14. And here again, the notes there show the long distributive property. They put 2a plus b plus 2, 2a plus b plus 2, and they go through and multiply. This times every one of these, so you have 2a times this, times this, times this. Then you have this times every one of those, and you have this times every one of those. Okay. All right, so we'll go ahead and write that down. So we're going to have the 2a is 2a times 2a plus b plus 2. And then we're going to have the b times 2a plus b plus 2. And then you're going to have the 2 times that. All right, then you're going to multiply this times all that and this and add all that. You can follow that. I'm going to show you a shortcut. Same rule as before. This squared, this squared, this squared. Then you take the different combinations. I want two things here, so I can take those two, double it. Take these two, double it. And take the last two and double it. And you'll get the same answer as when you multiply all that out. But what the tape is wanting you to see, and the teacher usually wants you to see the distributive property. When you multiply parentheses here, then you're going to multiply this times everything over here, and then this times everything over here. You're going to distribute this with everything here, then distribute that with everything here, and then you add like terms. All right, what you need to do now is to work the examples and the notes and just a lot of practice, practice, practice.